Alright, last video was covering volumes of rotation about either the x-axis or the y-axis using disk and washer method. What if it's a volume of rotation and it's rotated about a line that's parallel to the axis? What this is going to do is has a potential of shifting some of your r's. So let's say we have y equals square root of x, like we had in the previous video. But instead of rotating about the x-axis, I'm going to rotate it about y equals -2. So this line. And let's say I'm going from x equals 0 to x equals 4. So I've got these vertical lines and y equals 0. So this is the area I'm defining. And I'm rotating it about this line, y equals -2. Well, if I made a three-dimensional shape, it would be something sort of like this. So we can tell because the axis of rotation and the area have a gap that this will be washer method. But what is going to be our big R and what is going to be our little r? Well, big R is going to be this, little r is going to be this. Oh, also because this is parallel to the x-axis, we'll be using dx. So we know we're going to use dx, and we know we're going to be using washer. So we look at our big R and our little r. Remember that from the x-axis to the curve, that is always y. This distance is 2. So it looks like my big R is going to be y plus 2. Little r is going from the axis to the near edge of the curve, or of the area. So that is going to be a fixed amount. That looks like it's going to be 2. So if I set up my volume integral, which for washer method looks like this, in this case we use dx. My bounds in x are from 0 to 4. Big R in this case is y plus 2. Little r is 2. And again, because this is dx, we have to make sure our y's are in terms of x. So we take y equals square root of x and substitute. We need to FOIL this one out. This is going to be a little bit longer to solve out. I'm just going to work out a little bit more. Just enough to show you that this is integrable. It's just going to be a few steps. Now, this happened to be washer method, but it will sometimes be disk method if you're rotating it about a different axis. Let's say we had y equals square root of x, and we're rotating about x equals 4, and the same area defined. So y equals 0, x equals 4. So because there's no gap between the axis of rotation, which is vertical, therefore dy, and the area of interest, we know we're going to use disk method. So we only have a single r. It's going to be from this axis of rotation to the edge of our area. This is our single r. Now how do we express this r in terms of either x's or y's? Well, we know that this distance has to be by definition x. When we go from the y-axis to the curve, that's always x. This whole distance is 4, so it looks like r is equal to 4 minus x. So that's our basic formula for disk method. Bounds are going to be in terms of y. So if we're going from 0 to 4 here, using this function, y goes from 0 to 2. And your r is 4 minus x, which is squared. X, again, has to be rewritten in terms of y, because this is dy. because it's rotated about a vertical line. So if we invert this equation like we did in the previous video, x equals y squared, our volume is going to be this integral. You would FOIL this out and then integrate using power rule. Probably recommend you have the pi factored out, just because it's easier. Always factor out your constants before integrating integrals. Okay, so these are two examples of rotating it about an axis that is a little bit different from the axis of rotation. Hope this helps.